So this is a balance loop Sudoku hybrid. As we'll see, the balance loop rules are going to work a bit differently in the Sudoku variation than they would in typical balance loop. For instance, up here in box 1, this dot right next to an edge, going up it can only travel one cell, and so typically that would mean going down it can only travel one cell and would have to turn here. But if it turns here in the Sudoku version, then we're making these two digits equal to each other, and we have a repeated digit in the column. So that's no good. This has to continue onwards. This has to take at least two down. This has to continue. This has to continue. This one we know has to continue in at least one direction, left or right, although because it's not against an edge, we don't know which yet. This edge now has to come down. And for dots like this, which are in the center of a cell as opposed to on an edge, you can think of it as summing either these equal to these, or simply this equal to this. Either one is valid because you're just adding or subtracting the same cell from both ends. But either way, we're going to notice that this cell is now summing at least these three digits. And if we were to extend this, then we would have one digit equal to the sum of at least 4, which is going to be at least 10. So that's no good. This has to turn. This has to turn to avoid closing the loop. Now we get to a bit of a tricky decision or a deduction involving this dot right here. And the idea is what happens if it does not go to the right, if it goes straight up and down. Well, once again, these two digits cannot be the same, so this is going to have to keep extending. And now we run into a problem where this digit is going to be the sum of these three. This digit is going to be the sum of these three. And we have these 6 digits that all must be unique, so they have to add up to at least 21, summing to these 2 digits, which can add up to at most 18. So that's no good. We know that this, in fact, has to go to the right. And now, the tricky step to see here, but the necessary one, is to ask what happens if it turns downwards, like so. Now that we're turning, this digit cannot be here in the box, which is going to stop this from going up because then the dot would be broken. So this has to go down. And now we run into exactly the same problem where we have these 2 digits equal to the sum of these 6 digits, which is never going to work under Sudoku rules. So that tells us that this does not turn down, which is going to put a lot of pressure on this dot in the bottom left box, because this dot is in the center of the box, and it can't travel one cell in every direction. So for instance, if I were to put an X here, how are we going to satisfy this dot? And the answer is we're not. No matter how you do it, if I try and go up and down, well, these 2 digits have to be the same. If I go left and up, then these 2 digits have to be the same. This dot has to travel at least 2 in some direction. And with this X in the grid, the only way it can do that is to go out here and join to this guy. Now we run into this interesting pattern where this one is taking at least 3 digits out here. If it continued to take a 4th, then once again it's broken because this is going to be adding up to at least a 2-digit number. And where are you going to get the 2-digit number on this side of this dot? It's not possible. So this has to end here. And now we run into a similar issue. If I were to extend it in this direction, now this digit is broken because it would have to be at least 10. So we can put another X here. We know that this either turns up or turns down to go to a single cell. So we have a single cell adding these 3. So the most this can ever be is 6. But this is also the sum of 3 digits. So the smallest it can in fact be is 6. So this is a 6. This is going to be a 1, 2, 3 triple. And either this digit or this digit are going to be the sum of these 3, which must therefore be 6, 1, 2, placing a 9 in one of these 2 cells and a 3 here. And this is going to be important for helping us break into box 1, because now this digit can no longer be a 9. It's summing 3 cells, so it must be at least a 6. And it's also summing these two cells. Before I go too much farther, let's ask ourselves a little bit about this one. Can it, for instance, be a very low digit like 1 or 2? And the answer is no, because no matter which way this circle goes, whether it goes straight, these two can't be the same digit, so it would have to extend one more, so making that at least 3. And if it goes down, again, if it stops here, these two would be the same, so it has to go down at least 1. And the smallest I can make this is a 1-2 pair, making that at least 3. In fact, if it does go down, then we run into exactly the same problem as before with these two connecting, or doing something like this, which would force that. But that's a bit of a look ahead, so we'll get back to that later. But the important thing to notice is that this digit is going to be at least 3, and because this is an 8, it can be at most 5. Now let's ask what happens if, now that we have this 3 down here, what happens if there's not a 1 or a 2 on this strip? And hopefully, obviously, the puzzle is broken, because the smallest of these would be a 4 and 5. This would have to be a 9, which it can no longer be. So there is a 1 or 2 somewhere on this strip. And similarly, if there was not a 1 or a 2 somewhere on this strip, then we're looking at 3, 4, 5 adding up to 12, which is definitely going to break this. So we have a 1-2 pair, in fact. And in fact, we can ask what happens if there's not a 1 on this strip. And once again, then we would be looking at 2, 3, 4 as an absolute minimum. And this would have to be at least a 9. So there's a 1 in one of these two cells, which means that this 1, 2 is going to be a 2 in one of these two cells. Now that there's a 2 over here, this strip can't have a 1. The absolute smallest I can make it would be a 1, 3, 4, which is adding up to 8. So 6 and 7 are no good here. This is an 8, this is a 1, 3, 4 triple, and this must therefore be 2 and 6. Now we can look at this digit, adding up these two. These can't have a 1, they can't have a 2, they can't have both a 3 and a 4, because that would break this. So they're adding up to at least 8. 8 is already taken, so they're adding up to 9. And they can't be 1, 8, 2, 7, or 3, 6, because 1, 2, and 6 are all taken up, so it must be 4, 5. That knocks the 4 out of here, places the 4 down here, and we get the 7 to finish off the box. Now that this is a 4, it must be adding up 1 and 3, but it can't go down here because of the 3 there, so it must go out this way. A little bit of Sudoku now. These 4s here are going to lock a 4 into the same cells. We have a 9 placed here, so that's going to be a 4-9 pair. The remaining digits up here are going to have to be a 1, a 5, and a 7. That's going to resolve our 1, 3. That resolves our 1, 2. I could have done this earlier, but actually, once we put this x in, I can force this line upwards. And now it's more clear what happens if this line stops here, is that we're getting either these two digits in the box to be the same, or we're getting this digit summing these 3, and it would have to obviously be a 7 summing 1, 2, 4, which is no good for a myriad of reasons, so this has to continue onwards. Now, a bit of a tricky thing to notice is what happens if this connects downwards. That's making this the 9, summing 1, 2, and 6. But now this 9, how is it going to be filled up here? It can't take 3 digits because we have 1, 3, and 4 used up in the column. So that would be the same logic as before, where we have these 2 digits summing 6 in the column. But it also can't sum these two because 1, 8 is no good, 3, 6 is no good, 2, 7 is no good, and 4, 5 is no good. So in fact, the 9 does not go down here. This turns up, placing the 9 here. This line now continues onwards. We can ask what would happen if I were to connect here, forcing this to continue outwards. And now we have these 5 digits, summing to at least 15. But these 2 digits, because they see a 7 and a 9, can be at most 6 and 8, which only reaches 14. So that's no good. These two don't connect, so this has to come up, this has to turn out. And now a similar question, what would happen if I were to connect here? Once again, that's forcing this out. And now I'm going to actually look at the loop in the other direction, which is to say, including the dots on the corners, and notice that the sum of these 2 digits is therefore equal to the sum of these 3 digits by this dot, which is equal to the sum of these 4 digits by this dot, which is equal to the sum of at least 6 digits by this dot, And so we have these two, which can be at most 15, summing to at least 21, which is no good. So these again don't connect. This has to continue. Remaining in this box, we still have to place 2, 6, 8, and 9. These two can't be 9. And now let's look at what happens if I try and turn this upwards. Then we have this digit summing both of those. But this obviously can't be a 9 in that case. And then we would have an even digit plus an odd digit summing to an even digit. So that's no good. This has to continue straight onwards. And now we arrive at what I think is one of the more fascinating steps in the puzzle, but also probably the most difficult to spot. And if you'd like, take a moment and see if you can figure out how I can tell the parity of this cell, even or odd. So the way this works, and the reason this works, is because we know this digit is going to be even. So that we know this line, wherever it ends, is going to sum up to a multiple of 2, whatever's on the left plus whatever's on the right will be the same. So 2x plus an even digit, the entire line will be even. The entire line is going to be equal to this entire line because of this dot. So this must also be even. We know that this is adding up to odd because it's 3 odd digits. And therefore, in order to make the entire column odd, this digit must be even, and is therefore not a 9, which places the 9 in this cell. Now this line can't stop here because we would have this digit have to equal at least 10. So this continues onwards, this continues onwards. This now can't turn up without closing the loop, so it turns down. This can't turn up without closing the loop, so it continues forwards. One thing I didn't do but could have done earlier was do a little bit more work with this cell. We know it can't be a 1, and if it was a 7, we're going to have the negative constraint come into play, because now these 3 are adding up to 11, but these 3 are also adding up to 11, and there would have to be a dot in this square, which there is not. So this is a 5. We can do a similar thing with the negative constraint on this row, actually, on this line, actually. If this were to be a 3 and this a 1, then we have 3 and 4 adding up to 7, and there would have to be a dot in this cell, which there is not. So we've got 3 and 1 in as well. And now we can ask if this can be a 7, because that's going to make this add up to 16. This, however far out it goes, is also adding up to 16. But then, whatever this is adding up to at least 16 plus 16 plus 2, which would be 34. Which hopefully is obvious is just going to break the column, because we would have at least 44, 49 plus 2, at least 51 in the column, which is no good. So this is a 1, this is a 7, and this side of the dot is going to add up to 10 in some regard. We can now do a little bit of shenanigans, knowing that this is going to add up to 10 in some way. Because we know these add up to 15, the rest of this column adds up to 30, but this sum is going to be the same as this sum, however far this line goes. So if this adds up to 30, then we're looking at something like this also adding up to 30. We can subtract the 9 and the 1, that gets us down to 20, and we could subtract the other side of the line, which will also add up to 10, and that gets us down to 10. These two digits have to add up to 10, they have to be 2 and 8, and that places the 6. Now the question becomes how to fulfill the 10 on this end. And it obviously can't go 4 cells, because if it goes 4 cells, these would have to be 1, 2, 3, and 4, but the 1 is already taken up. If it goes 3 cells, it's going 2, 3, and 5, and it can't close there, so it'd have to turn up here. And if it's going 2 cells, it turns up immediately. But this is going to have an impact on this dot, which, similar to the bottom left corner, is a dot in the center of a box. So it needs to go 2 in some direction. It can't go 2 in this direction because that's going to run it off the edge of the grid. It can't go 2 downwards for obvious reasons. And it can't go 2 in this direction either, because that's going to cause this digit to be far too large, adding up 4 digits to make a singular one. So it has to go 2 upwards. There's now 2 places you can make progress. The one where eventually we're going to break into the puzzle is through here. But let's take a look at this dot for a moment and see what we can do with it. Because if this dot were to connect up here, we run into a problem. It can't connect here, because that's going to close off the loop in that side. It can't go here, because that would make these two digits equal. And if it tries to go to the right, that's forcing this guy out, and now this digit is summing these three. But this digit can't be a 6, 7, 8, or 9, so that's no good. And we know that this does not connect here, which means this must connect there. This is now a 9 plus something, so this is continuing out at least one more cell. And in fact, if I tried to stop there, we would have a minimum of 9 plus 1 plus 2. In fact, this can't be a 1 or a 2, so we would have a minimum of 9 plus 1 plus 3, making 13. But these can never sum to 13 without using 7, 8, or 9. So this has to continue at least one more. And there's a bit more we can do with these two, noticing that the fact that this is quite large is going to put pressure on this cell and whether or not this reaches the edge of the grid. But we'll get back to that in a second. For now, I want to focus on this area, and there's more or less two ways to make progress here. If you're fine with a little bit of look ahead, you can notice that this coming outwards and making a 2, 3, 5 here is going to quickly break. But if you want to take a more picky approach to this puzzle, the key thing to focus on is this cell, which sees a lot of digits. It can't be a 1, it can be a 2, it can't be 3, 4, 5, or 6, but it can be 7, 8, or 9. And as we mentioned, this dot only has one way it can go 2 digits, so the other one has to be a singular digit, so obviously 9 is no good here. And the key thing to notice is that if this goes forward and turns, this has to be a 2, 3, 5, because the 1 here eliminates every other option for a 10. If, on the other hand, it stops here and turns, then we're looking at these two cells adding up to 10. They can't be 1, 9, and they can't be 2, 8. So they would have to be 4, 6, or 3, 7. But this digit also has to sum these two, which, since neither of them can be a 1, this is going to be at least a 5, so this has to be at least a 6. So in fact, it could only be a 7 there and a 3 here. So no matter what, we know there's going to be a 3 in one of these three cells. That's going to force a 3 into one of these three cells, and we also have two 1s looking into this box, forcing a 1 into one of these three cells. This obviously can't be the 1 because it would break the dot. And now we can start to ask ourselves how this line works out. If this is a 3, we could place 1 and 2 on this and it would turn. If this is not a 3, then we're looking at a 1-3 pair here. This could either be just these two adding up to a 4, or it could extend one more, and we could be looking at 1, 2, 3 adding up to 6, 1, 3, 4 adding up to 8, or 1, 3, 5 adding up to 9. But the important thing to notice is that in none of those options does this group have a 5 in it. And so because the 5 up here is going to force a 5 down to the bottom of this box, and that eliminates the possibility of this continuing 1 forward and becoming a 2, 3, 5. So we now know this does turn upwards. As before, these two have to add up to 10, but this one also has to be the sum of at least 5. Can't be 6, so it has to be 7. Makes that a 3. This clearly can't be 7 or 8 now, so that's a 2. And now that's going to help us reduce the options for this dot. If it were to go and connect like so, then this edge, in order to escape, has to come out through here. And we've got this digit summing these 4, which is already at least 9, so this would be a minimum of 13, which is no good. So this does not connect here. This dot has to go straight across. It has to go straight one more, otherwise these two digits would be the same. Turns in the corner. In order to escape, this line has to come up here, makes that turn, and now we have 7 equal to the sum of 2 and 5. That resolves the 4, 5 in this box. places a 5 in one of these 3 cells. Now we can start to look at the options up here. This cell can no longer be a 1, 2, or a 3, so the smallest it can be is 4. The smallest I can make these two add up to is 1 and 4, which, if you notice that this adds up to 15, even if I make this extend across the entire line, the most I can make it add up to is 30. So the most I can make this add up to is 15. And we're 1 degree of freedom away from that. So this is either a 4 or a 5. Can't be a 5, so it's a 4. This is either a 1 or a 2. Can't be a 2, so it's a 1. And so in fact we have 14 here, we have 14 on this end, and we have 2 sitting outside. The remaining digits up here are going to be a 3, 5, and 6. But if you notice that 6 in this box locks 6 into one of these 2 cells, that forces this to be a 3, making this a 5, 6 pair. The candidates here, just looking at the numbers in the box, are going to be 2, 6, 7, 8, and 9. This can't be 6 or 7. This can't be 2. And in fact, if I were to extend this line outwards, then we close the loop, so this has to turn. The options for this cell look to be 1, 4, 6, 7, 8, 9. Obviously it can't be 8 or 9, because that would add up to at least 10 and break this cell. This now is going to have problems being a 6. If it were a 6, then we would need these two to be either 1, 5, which is impossible, or 2, 4, but if we have 6, 2, 4 here, then we have no digit to place in this cell, so this can't be a 6. Similarly, if I try and make it a 7, then 1, 6 is no good because we have the 6's here and here looking at these. So in fact, neither of these can be a 6. 2, 5 is also no good because we have the 5's in both of the boxes, and 3, 4 is no good because we have the 3 and 4 in box 2. So this is not a 7. In fact, this is not a 2, so we get an 8, 9 pair here. That eliminates 8 and 9 from this cell. If this is an 8, can't be 2, 6, so we're looking at 7, 1. If this is a 9, then it has to be 2, 7, and this would be the 2 and that would be the 7, so this is never a 4. And we always have a 7 in one of these 2 cells. The remaining digits in this box are now going to be 2, 6, and 7. That actually makes a 2, 6, 7 triple. So I can fill in these digits as 3, 8, and 9. These 3 digits are going to therefore be 1, 4, and 7. That does resolve which of these 2 is the 7. This has to be a 2. These are not 2, so this is 2. This is 6. This is 7, making this a 9. That becomes our 8. We could take 7 out of those 2. And that's a lot of progress in the top right. Now we're going to sort of shift our way back down to the bottom left now that we've got some more information about these digits. So these 3 are going to be from 3, 4, and 9. This one can't be a 3. These 3 are going to be from 5, 6, 7, 8. And in fact, the 6 is here. Eliminate 6 from here and resolve our 6, 7 pair. So we're going to have a 5, 7, 8 with the 7 down in one of these 2. And in this column, we're looking at 2, 7, and 8 with, again, the 7 down in one of these 2 cells. So we actually get an X-wing on 7s here, where either the 7s are going like this or going like this. That will allow us to do a couple things. For one, we can pencil mark 7s in this box. But more importantly, we know that there is definitely going to be a 7 down here, along with a 4. So we have a 4 and 7 adding 2 other digits to make these 3. So let's have a look at the candidates for these cells. We have left 2, 5, 6, and 8. This one can't be a 6 or a 2. If this one were a 2, we run into problems rather quickly because then we have an 8 here and this becomes a 5, 6. But then in this case, these 2 would add up to 11, these 2 would add up to 11, and we would need a dot between the 2 groups, which we do not have. So this cannot be a 2. And the fact that this can no longer be a 2 narrows down the candidates for this sum quite a lot. We're looking at only 5, 6, 9, which would make 20, 5, 8, 9, which would make 22, or 6, 8, 9, which would make 23. 20, 22, or 23. And now down here, we've got a 4 and a 7 for sure, so that's adding up to 11. So if we subtract 11 from all of these options, the remaining 2 digits here are going to add up to either 9, 11, or 12. So let's look at what options we have for that. If 9, 1, 8 is no good because there's nowhere to place a 1 here. 2, 7 is no good because we've used up the 7 already. 3, 6 is no good because there's nowhere to place a 6 here. And 4, 5 is no good because the 4 over here is already used up. So it can't be 9, this can't sum up to 20. So this therefore can't be a 5, 6 pair, meaning that this is not 2 or 8. This is a 5 or a 6. We actually get a 5, 6, 8, and we can keep going, placing a 2 there and an 8 there. Well, let's real quick look at what happens if I were to make this a 12 and try and make 2 digits here sum up to 12. 4 and 7 are already used up, and with them come 4, 8, and 5, 7. So we would have to go 3, 9. But this is the only digit that can be a 3 or a 9. 3 and 9 are removed from both of these two. So 12 is no good either. So we in fact know that the 2 excess digits here, we have 4, 7, and then 2 digits adding up to 11. And that can be either 8, 3 or 2, 9, both look like valid options. But we know they're adding up to 11, so these must add up to 22, making this a 5, 8 pair, and placing the 6 down here. Let's go back up to the top right now. Sorry for jumping around, but I realize there is more we can do with this dot at this point. And the question to ask now is what happens if it goes straight up and down. Obviously this would have to turn, and we're looking at least 4 adding up these 2 digits, where this one can't be 1, 2, 3, 4, or 5. So that's obviously not going to work. This has to turn. And now it can't turn up here because once again these have to close, and we're looking at, I mean, the only way this would work is if this is a 4 adding up a 3 and a 1 here, and not only does that close the loop, but also these digits are going to make a number far too large. So this does not turn up, this turns down. This, in order to escape, has to connect here. We have a couple options for this now. This cell can't be a 1, 2, 3, 4, or 5, so it's 6, 7, 8, or 9. If the loop turns here, then these 2 digits are the same. This just becomes an 8 or a 9. But if it continues, then we're looking at this digit being the sum of these two, which does just work if this is a 9 and this is a 6, 3. Either way, we know this is an 8 or a 9, and this is either a 6, 8, or 9. That's actually going to place 7 in the row because 7 cannot go in either of those 2 cells. That's going to place 7 down here as well. We can remove 7 from there. And now that's going to have an impact, believe it or not, on this dot down here. Because this dot, it can go 1 in this direction and it can go 1 in this direction. But it needs to travel 2 in some direction or else duplicate a digit in the box. So it's going 2 upwards. And now we can ask about these digits. The options they have left just based on the digits already placed in the row is 4, 5, 8, and 9. But this one obviously can't be a 9 because it's summing a single digit with at least 2. And this one similarly can't be a 9 because if I make this a 9, then we've got this adding up to at least 10. This would have to travel 2 in some direction, but it can't. It can only travel 1. And that's going to give us a 4, 5, 8 triple in the row and place the 9 here. That now is going to have a major impact on this, giving us the 3, 4, 9. We knew this had to be 4, 7, and 2 digits adding up to 11, so now it has to be 3 and 8. The 8 goes here with 7, 2. That resolves the 7x wing. This becomes a 5. This can no longer be 9. These 3 digits are going to be 4, 6, and 8, where this can't be an 8, this can't be a 6, and this can't be a 4, making these two digits 1 and 5. Another thing I could have done earlier is noticing this line. Now that we have this 5, 8 here, if this were to be the 5 and this the 8, we're looking at 14 up top and 14 down below, and once again there would have to be a dot in the middle, which is no good. So this is the 8, this is the 5. That's going to make this a 4, 8 pair. One of these has to be an 8, making one of these to a 9. This can't be a 9, because then if this was an 8, it would have to turn this way making a 9, or this way making a 9. And if this was an 8, this would become a 9. So this can never be a 9. So the 9 in this column is suddenly eliminated from all of these cells, and it must go here. That still doesn't tell us if this turns or goes straight, but we do know it can no longer be an 8. That's a 6 or a 9. This is 6, 8, or 9. This is now no longer a 6 because we had that 6 there a while ago. These two can also no longer be a 2, so this is in fact a 1, 3 pair. This can no longer be a 3, and now we do know that this does not continue down, making 9, 6 plus 3. So it must turn. Don't close the loop, so this goes over here. This now can either be a 4 or an 8, it seems. If it's a 4, it's summing 1 and 3, and if it's an 8, it's summing 1, 3, and 4. Both of those seem fine. This 9 is going to have to make this a 9, which does in fact place the 9 down at the bottom. Doesn't tell us which two of these is an 8, because if this is an 8, it can still turn into this one. These two digits are going to be 1, 2, and 5. This can no longer be a 2 because of the 2 in the top right corner, so that's a 2. That's going to place the 2 in this box. These three are selected from 1, 3, 5, and 6. This one can be at most 5 in order to make this 9 work. Similarly with this one, so that's actually going to place 6 in the row. And we've got a 3 in one of these two cells, which pairs up with the 3 in one of these two cells to make an X-wing. That's going to eliminate 3 from here. Resolve our 3, 8. That is going to make this a 6, 8, 4, 6. This now does become an 8, so this has to continue onwards. This loop escapes through there. These two cells are going to be 4 and 5. This 6 looks up and resolves this 5, 6. That's going to eliminate 5 from here. This is resolved by the 8 up here. That finally now does give us our 8 here. If this were to continue upwards, we would be summing 3 digits to at least 13. That would have to make a single digit down there or there. So it does not continue upwards, and in fact this must be a 1, making a 9, so these two connect. This then becomes our 3. In order to make this 9 work, it has to be 2, 3, and 4, so it continues upwards and connects there. This 8 is coming down to connect with this loop, which must turn and connect there. And all that remains now is to finish off the Sudoku side of things. So that's how to solve this puzzle. Hopefully this variant was interesting. I don't know if something like this has been done before, but I'm pretty happy with the logic involved in this puzzle and the way in which the Sudoku and the loop complement each other. And I'm also pretty happy that I was able to work out a grid that had just white dots in it, which was pretty cool. Yeah, but that's the solution to this puzzle. Hope you enjoyed, and I'll see you guys next time.